Fine. So today the paper we are discussing is the first term, grade 13 first term paper from 2018, Devi Balika. Right. So grade 13 first term in the sense mainly we'll be covering mechanics, heat, oscillations, waves and oscillations, and heat, and I think a little bit of gravitational field. There must have been some electric field also. Right. So let's see. Right. So let's focus on the first few questions immediately. Pxt of the equation P equal a minus x squared divided by bt squared represent power, displacement, time, and time respectively, the dimensions of ratio A over B. Right, that's the first question. Now the equation they have given, the answer first one, the equation they have given is P equals a minus x squared, all right, over bt squared. Now few things we can say. Oh, this is simple. You should not make it very complicated. Dimensions of power is equal to dimension of this thing. Now on top you don't have to worry about x, because a minus x squared, this is, since they are subtracted, that is same as dimension of a, and at the bottom we have dimension of bt squared. Now the question is, what are the dimensions of a over b? Then I can keep a over b on the right side and take this t squared up. So dimensions of power multiplied by dimension of t square time squared is equal to dimensions of a over b. This is how you have to do this question without making it complicated. X doesn't have to be considered, because dimension of a and dimension of x squared should be equal. What's the reason? Subtraction. When you subtract two quantities, you can consider that their dimensions are same. Right. So this is it. Dimensions of power, we know it is ml squared t minus 3 into dimensions of time, it's t squared, time squared, t squared, that is dimensions of a over b. So dimensions of a over b will be equal to ml squared t minus 1. ml squared t minus 1. Therefore the answer is second. Correct? So if you have any objections, let me know in the chat. This is the answer. ml squared t minus 1. Yeah. Second one, a percentage error of 0.8% occurred when taking measurement of 2.5 millimeters from a certain measuring instrument. The least count of the instrument is. Right. The second one also should not be a very difficult question for you, because it's just a normal percentage fractional error. Percentage fractional error, it's equal to least count divided by reading into 100%. Right. Least percentage fraction error is 0.8. Least count not given. Reading, they have given it as 2.5 millimeter. 2.5 millimeter into 100. So least count, it's going to be equal to 0.8 into 2.5 over 100, and 0.8 into 2.5 is 2 over 100 is 0.02 millimeters. 0.02 millimeters. Yes. Since they have not given the unit for the final answer, but there is only one answer with a 2 in it, that is the third answer once again. So I think we can go ahead with that, because they should have given the units, in what unit we are supposed to find, but they have not mentioned that. And yeah, and there's no other answer with 2 in it, because if the answer is in centimeters or meters, we might have to be mindful about it, but there's only one answer with 2 in it, and they are asking it their final answer in millimeters. Done. Sorry. Third one, the magnitude of the resultant of two equal vectors is equal to the magnitude of one vector. The angle between the two vectors is interesting. So there is this equation you have to know. The equation is this, people. This is Roman 3, right? Roman 3. see if you can remember this. When two vectors are equal in magnitude, when two vectors are equal in magnitude, we can say the resultant vector is equal to 2f cos theta by 2. This is the equation, given that the two vectors are like this. The vectors are like this, f and f, and the angle between them is theta. Okay, but in this question they have told, r is also equal to what? F. That is what they have told. So instead of r, if I substitute f is equal to 2f cos theta by 2, and that means half equals cos theta by 2. Instead of half, I can put 60, right? Instead of half, I can put 60, cos 60 actually. Cos 60 is equal to cos theta by 2. So that means theta by 2 is equal to 60. I'm getting theta is equal to 120 degrees. 120 degrees. So the answer is this one. Which one? Fourth one. Yeah. And if you want me to represent that in a diagram, when you have two vectors like this at an angle of 120 creating between them, this is one vector, this is another vector, f, and yeah, and the resultant is this. R is also equal to f. This is what happens when the angle between them is 120, remember. Okay, right. And then fourth one. What is the fourth one? Consider the following statements made regarding sound. Velocity of sound in air increases with temperature. Yes, we can say it's correct. Why is it correct? Because we know speed of sound in air is equal to square root of gamma RT over m. So obviously when you increase the temperature, speed of sound in air should increase. So A is correct means this is wrong, this is wrong. Loudness of wave depends on frequency. Wrong, no people, wrong. Because loudness depends on what? Loudness depends on amplitude. Loudness depends on energy. How loud you are depends on how much energy you put. Depends on energy. So B is wrong. If B is wrong, this is wrong. It's either 1 or 5. Pitch is determined by the amplitude of the wave. That is also wrong. Who determines the pitch? Pitch depends on who? Pitch depends on frequency, not frequency. Okay, when I say energy, loudness depends on energy, or in other words, amplitude. Energy depends on amplitude, right? Simple. Therefore, the answer for this part, it's going to be 1. Done.
Excuse me, sir.
Yeah.
So they have asked for the false statement, sir.
Oh gosh, sorry. Thank you. They asked for the false statement. We'll leave it like this. Thank you for finding it out. Therefore, I will have to reevaluate these answers. So B and C are false. I think I should have underlined it. Yeah. False statement. Yes. False statements B and C are false. Therefore, fourth answer. Sorry. Right. So 2, 3, 4, 4. Yeah, these are relatively okay. These questions not very difficult. Right. All right. First, the fifth one. The distance traveled during the first 3 seconds by an object which falls freely under gravity is equal to the distance traveled during the last second. The time of flight of object is in seconds. what is it? 1357. Distance traveled during the first 3 seconds by an object falls freely under gravity is equal to the distance traveled during the last second. The time of flight of the object is time of flight of the object. Okay, now how do we do this? Fifth one. Right, it's see if you can remember this part, people. I'm just drawing like this. Fifth one. One, two, wait, one. Yeah, it goes like this. Sorry. Yeah. So when time is equal to 0, when time is equal to 0, here this is time is equal to 0. Okay, and this is time is equal to 1 second. Time is equal to 2 seconds. Time is equal to 3 seconds. Time is equal to 4 seconds. Time is equal to 5 seconds. Right? Okay. So during each second, you must have done these things when we were doing motion under gravity. We know during each second, the distance travel during each second. The distance travel during each second can be marked this way. This is the first second, during the first second, then during the second second, during the third second, during the fourth second, during the fifth second. This is 5 meters. This is like 5 meters. This is 5 meters. And how much is this second one? It will be 15 meters, and after that it will be 25 meters. And then it will be 35 meters. Then it will be 45 meters. Okay, 45 meters. I mean, each second, the distance traveled during first, second, third, fourth, fifth second, that will have a ratio of 1:3:5:7:9. It goes on like that. So during first second it will be 5, during the second second it will be 15, during the third second it will be 45. So during the first 3 seconds, according to the question, during the first 3 seconds, how far does it fall? Distance traveled during the first 3 seconds. Distance traveled during first 3 seconds, it's equal to 45 meters. And the other thing, false and free are equal to the distance traveled during the last second, and this should be the last second. So fifth second should be the last second. Understood? Fifth second should be, so fifth second should be the last second. Hope you all can agree with me on that. I mean, you don't have to, you can do this with equations also, but I think this is easy, right? This is easy if you can remember this. So the time of flight of the object is how many seconds? 5 seconds. It's actually falling 5 seconds, because during fifth second it will be falling 45 meters, and during the entire first 3 seconds, during the first 3 seconds it will fall a distance of 45 meters. So if 45 meters is the distance it travels in during the fifth second, total time should be 5 seconds. That will be easy, right? That way if you consider, it's easy. So fourth answer is the best option. Right. Sixth one. The maximum kinetic energy, mass, and amplitude of an object performing simple harmonic motion are E, M, A respectively. The period of motion is given by. Okay, that should not be a difficult one. Maximum kinetic energy. No, maximum kinetic energy. Maximum kinetic energy now in simple harmonic motion. In simple harmonic motion, right? Never mind. That is given by E, and the equation for that is, people, half m omega squared a squared. Half m omega squared a squared. I mean, you can write it this way: half m v maximum squared. Half m v maximum squared. That is half m a squared or omega squared a squared, because v max is because v max, the maximum velocity of an object performing simple harmonic motion, is omega a, if not a omega. All right. And what else they have given? They have given mass. Yeah, mass. They have given capital M, no? Capital M mass. Sorry, capital M. So let's go with capital M. And amplitude is given as A. Now, period of oscillation is what they are asking us to find out. Now, period of oscillation means, now first let's find omega, no? Omega. Right? You can see omega squared there. Omega squared is going to be equal to 2e over ma squared. 2e over ma squared. Why am I finding omega squared? Because then I will know omega square root of 2e over ma squared. Period of oscillation of the object performing simple harmonic motion is given by 2 pi over omega. 2 pi over omega. So t is going to be equal to 2 pi into 1 over omega is the reciprocal of this one, square root of ma squared over 2e. Square root of ma squared over 2e. I think they have taken this a out of the square root. So t is equal to 2 pi a square root of m over e. 2e, sorry, m over 2e. Is there an answer like this? Yes, the second one, right? Second one. Yep, good. That's the answer for the sixth one. And then moving on to the seventh one. Two waves traveling in a particular medium have same amplitude, frequency and wavelength. They have same amplitude, frequency and wavelength. They move towards same direction with 90 degrees phase difference. If the two waves are superimposed, the resultant wave then compared to the initial wave has what? I mean, they are moving like this. They have the same frequency. They have the same frequency. And they are moving at 90 degrees phase difference. No, people, 90 degrees phase difference means when they meet, no, when you say 90 degrees phase difference, if you draw a phase diagram, it's going to look like this. This is the phase diagram. I mean, displacement with phase angle, and what is this total angle? 360 or 2 pi, no, 2 pi for one whole wave, and here it is 180, if not pi, and 90 is here. So if the waves are meeting, if those two waves are meeting, then we have to consider two waves which meet like this. See if you can understand. Wave 1 and then wave 2 and then the resulting wave. Let's try to draw them. First wave, wait a minute. I think I should use reference lines. Then it will be easier for us. I'm going to use reference lines so that it will be convenient for us to draw it and finish it off. The light green line I'm drawing, they are the reference lines. Wait a minute, sorry. They have same amplitude, same wavelength, same frequency. That means they both look alike. But the problem is, if you take the first wave, if I draw the first wave like this, wait a minute. I draw the first wave like this. I should draw the second wave 90 degrees phase difference. I should draw the second wave like this, no, people. This way. This is how we should be drawing. Correct? Then I have to add them both. Now see here, when I add them both, this plus this, these two added, and then you will get the final result. Here we have a maximum amplitude 0, so here amplitude is this, and here we have maximum amplitude 0, again this. Here we have 0 minus, wait a minute, here, weird, and here we have the middle, we will have this, and here we have a maximum amplitude once again, the middle, maximum amplitude once again, and here what about, yeah, this point, okay, this point, minimum amplitude once again, and here also minimum amplitude, maximum, minimum. What kind of graph do you think we can expect here, people? Is it a graph like this? Yeah, looks like it's going to be a graph like this. This is how they will combine. Yep, this is how they're going to combine. Yes, this is how they are going to combine. So tell me about this. Did you understand? This is how the graph is going to be. So what is the frequency now, people? Frequency, in wavelength, amplitude, same wavelengths and speed, but different amplitude will be same. No, maximum amplitude will be here. Yeah, we don't have both in the same. Or okay, where? What about this one? Oh no, wait. I think I made a mistake. Sorry, wait. Points are correct, but the way I do the lines, maybe there's a problem there. So from here to here, it should go up and then come back down, because here it's yeah, because here between this point and this point, I should draw the lines for some more lines in the middle. See, right, these are the other reference lines. I should have drawn. This one went a little, it's not the perfect one. Right here, this is the lines, and I mean what I'm trying to tell you here is this. If you notice carefully, this part, the first part of the graph, both are in the positive side. And but this is increasing, this is decreasing. Decreasing. Will that be more than this? That's what I'm wondering here. If you take the middle part, it will be above now, people. It will be this. It will be above, I think. The midpoint will be the maximum. Then this will go down. This will go up. Midpoint must be maximum. So I think it should be like this. From here to here, it goes up. After that, goes down, and then again goes up. I think we will get a resulting graph which looks like this. Anyone else who got a graph like this? A graph like this, and it is greater than the amplitude there is greater than the original amplitude. Yeah, this is the amplitude, and this is the other amplitude. Because this part, the amplitude will be above, so they won't have the same amplitude, but they will have the same frequency. And so this is what's happening. Therefore, if you, when these two waves combine, you get a combined wave like this. Once they combine, you get the wave like this, and so they have different amplitudes, but they have different amplitudes. The amplitudes are not going to be same, because the light blue color I have drawn, that is the indication of the previous amplitude. But the new amplitude is above that, but the frequency and wavelength are going to be same, because look at the wavelength for the previous one. For the wavelength for the previous one is this now, and the wavelength for this one is this. So lambda, it's not different, it's the same. Lambda means from peak to peak. it will be the same distance. This starts from this point to this point and slightly starts from left and slightly off left. So it's the same thing, same wavelength, but different amplitude, and same wavelength. Frequency also will be same if wavelength doesn't change, and then wavelength and frequency must be same. 8, 9, 10, even 11 will we have enough? Give me a second. Right, eighth one looks like it's about a prism, and let's quick. The angle of incidence is 32 degrees. Angle of incidence is 32 degrees. Yes, I1 is 32. We'll take it as I1 is 32. Find the angle of prism should be rotated to get the minimum deviation position. Right, we need to check what's the minimum deviation position. How do you find the minimum deviation position? Right, 32. 32. So first and foremost, first and foremost, let's try to find out the angle of deviation. What is the angle of deviation now? Angle of deviation we can find out using this equation. N equals sine A plus D over 2 divided by sine A by 2. Correct? So N is given to us 1.5 equal to sine of 60 plus D over 2. D is the minimum deviation, D over 2 divided by sine 60 by 2, that is sine 30. So yeah, then I'll be getting 1.5 equal to sine 60 plus D over 2. At the bottom it is sine 30 is half. So if I multiply it up, I'm getting sine 60 plus D over 2 is equal to 0.75. 0.75 can be written this way here. Sine inverse 0.75 is 48 degrees 35 minutes. This means sine of 48 degrees 35 minutes, that is equal to 0.75. That is the meaning of this. So instead of this, I can write sine 48 degrees 35 minutes. So 60 plus D over 2 is equal to 48 degrees 35 minutes. And I have to multiply this by 2. 60 degrees plus D is equal to, when I multiply 48 by 2, it is 96. When I multiply 35 minutes by 2, it's 70 minutes. So it's 1 minute and 1 degree and 10 minutes. So final answer is going to be 97 degrees 10 minutes. Therefore, D will be equal to 37 degrees 10 minutes. 37 degrees 10 minutes. That is the value of D here. If that's the value of D, what should I do? That's the value of D. Okay, wait a minute. That's the value of D. So I need that. If that's the value of D, there's another equation where we can find out the angle of incidence. What is that equation, people? D is equal to 2I minus A. That is this I when the angle of deviation is minimum. That is that I. When you have a prism which undergoes minimum deviation, this one. This is how it will look like with minimum deviation scenario. Yes. So angle of incidence and the angle of emergence both will be I. This is that I. So we have to find that I. To find that I, D is okay, 37 degrees 10 minutes equal to 2I minus 60. So 2I is equal to 97 degrees 10 minutes. I is equal to 48 degrees 35 minutes. No? Same. Therefore, I have to rotate it how much? I need to increase the angle by 16 degrees and 35 minutes. To increase the angle, I need to rotate the prism this way. So should be rotated this way. Yes, correct. Because the ray will be there without changing. So if you rotate it this way, should be rotated clockwise. Should be rotated clockwise to increase. Should be rotated clockwise to increase angle of incidence. Understood? Because the ray will not go anywhere. It comes from the ray box or some monochromatic light source, and when you rotate it to the in the clockwise direction, the angle of incidence will increase, because this normal will keep rotating to the other side. If you want me to put that into a diagram and explain it to you, this is what's going to happen, people. The ray will not change. So I have to draw a line which is parallel to this. Okay, then I'll lift it and put it here. Ray, okay, parallel ray. And to get a larger angle, your prism must be rotated like this. Then only the angle will improve. Right, people? Prism doesn't look in the best of shapes, but you get the point, right, Mithin? So see, the angle has increased than this, correct? Angle has increased to what? 4835. But remember, you don't have to rotate it by the entire amount. You have rotated this one. Second one is the answer. Very good. Second one is the answer. Second one. Okay, because it's already at 32 degrees. I need another 16 degrees and 35 minutes. So should be rotated. Should be rotated further by 48 degrees 35 minutes minus 32, that is 16 degrees 35 minutes. Understood? Right. So the answer is second for that. Ninth one. That's a good question, right? How many of you got this answer? Can I know? Hasna got it? Hasna has got it, no? Good, right. Convex lens of focal length 5 cm is used as a simple microscope. The near point of the observer who uses this microscope is 30 centimeters. The minimum and maximum angular magnification of the instrument is good one. Right. So they have the information they have provided here. This is the explanation for question number 9. They have given us f is equal to 5 centimeters, and they have given d, that is equal to 30 centimeters. For a simple microscope, okay, for a simple microscope, what is the minimum value of m, people? Angular magnification. The minimum value is when you get the image at infinity. That is given by d over f. D over f is equal to 30 over 5, that is 6. And maximum angular magnification is d over f plus 1. You have to remember this equation, d over f plus 1. So 30 by 5 plus 1, that is 7. 6 plus 1, 7. 6 and 7 are the answers. So answer is which one? Third. If you want another additional information, I can say final image at d, no, final image at infinity here, final image at infinity, and in this one, final image at d. Right, good. And now we have the 10th one. The two fixed points of a thermometer are marked incorrectly as -1 degree Celsius and 97 degrees Celsius. The accurate value of temperature 4 degrees Celsius measured from this thermometer is weight. The two, you have to be a little careful here. The two fixed points of a thermometer are marked incorrectly as -1 degree Celsius and 97 degrees Celsius. The accurate value of a temperature of 40 degrees Celsius measured from this thermometer. So this thermometer is measuring 40. We have to find what is the correct one. Right. So we'll answer this question here. That is question number 10. And I will draw the thermometer horizontally for a change. Right, this is it. So we'll mark the correct ones on top. This is the correct value, means we know now the lower limit is 0 degrees Celsius, the upper limit is 100 degrees Celsius, and the accurate value they have measured is we have to find the accurate value, but the one they have measured is 40 from that thermometer. That thermometer shows 40, and what do you call that, lower limit and upper limit are this. So I have to find theta. And what is the equation I have to write, people? The equation is going to be theta minus 0 over 40 minus minus 1. Correct? Theta minus 0 means, yeah. And the one corresponding here is 40 minus minus 1. Equal to 100 minus 0 over 97 minus minus 1. That is what I'm getting. So this can be written as 100 over 98. 100 over 98, and theta it's equal to 50 over 49, that is 100 over 98 into 40 plus 1 is 41. And did anyone find the answer here, people? I'm getting 15 to 40 is 2000, 2050 divided by 49, 40.8, something like that. 40.8, 41.8. Oh wait, different answers. Why is that? Right, let's divide it then. Let's divide it quickly. Yeah, I'll divide it here. Yeah, okay, I'll divide it here. I will divide 2050 by 49. Correct? 4. 196. And in this we have 90. 90, there is only one. 49, 81. 41.8. Now I'm getting 41.8. How many of you got 41.8? I'm getting 41.8, people. I'm getting 41.8. Not 38. Shimra, if you're getting 38.2, you have taken 40 as the accurate one. That is wrong. They have measured 40 from this thermometer. The accurate value of a temperature of 40 degrees Celsius measured from this thermometer is. So 40 degrees Celsius is measured from this thermometer. And if this thermometer is showing 40, what should have been the actual value? That's the question. Okay. That's all. Question number 11. The distance between the two lenses of a telescope in normal adjustment is 55 centimeters, right? So they are talking about the distance between 2 points in a, sorry, the distance between two lenses of a telescope in normal adjustment is 55 centimeters. That means we know FE plus FO is equal to 55 centimeters. The angular magnification is capital M. A person observes that the magnification of image when looking through the objective lens is M by 100, focal length of the objective lens. Okay. So this is another point. A person observes that the magnification of the image when he looks through objective lens is M over 100. Right. Interesting question. Okay. So I think this is how we have to consider. So first when they look through the eyepiece, the angular magnification, when you look through the eye, when your eye is here, right, object will appear magnified, people. Yeah. So here M, it's equal to FO over FE. M is equal to FO over FE. And when the person looks through this is eyepiece, eyepiece, and this is the object lens. And when they look through the object lens, it's the other way around. What happens? They look through the object lens. Wait a minute. When your eye is here, then they have given m over 100, it's equal to then what? Fe over Fo. It becomes Fe over Fo. Fe over Fo. So this is equation 1, this is equation 2. If you look through the eyepiece, the equation for angular magnification is Fo over Fe. If you look through the object lens, it is Fe over Fo, that is m over 100. I think we should multiply 1 and 2. When we multiply 1 and 2, what will we be getting? We will be getting m squared over 100. Is it m squared over 100? That is equal to 1. M squared over 100 is 1. That means m squared is 100. That means m is equal to 10. Correct? M is equal to 10. M is equal to 10. They are asking for focal length of object lens. That means they are asking for F4. Right, then we know Fo over Fe is equal to m, and m is equal to 10 now. From that I can say Fe is equal to what? Fe is equal to Fo over 10. That is 0.1 Fo. F is equal to 0.1 Fo. The question is, what is the length of Fo? They have said here Fe plus Fo is equal to 55 centimeter, right? Fe plus Fo is equal to 55 centimeter. Then instead of Fe now you can put 0.1 Fo plus Fo, that is equal to 55. And that will give us 1.1 Fo is equal to 55. So Fo is equal to 50 centimeter. Fourth answer, right? Okay. So what they mean by m by 100 is when you keep the eye at object lens, it's like the opposites are going to happen. No? You have to put the object at infinity, so the rays will come and they will get converged here. So it should be Fe over Fo. And this is how you have to handle that question. I think I should separate the region for that question without to avoid any confusions. So this area is the explanation for question number 11. Okay. Right. Hari. Right. 12th one. The fractional change in density of a liquid of volume expansivity 5 into 10 power minus 4 per degree Celsius when heated from 20 degrees Celsius to 40 degrees Celsius is given by. Okay, the fractional change in density. Interesting. So we know when you have there's a liquid which is at 20 degrees Celsius, its initial density will take it as rho naught, and we are heating it, and it turns to, when you heat it, it turns to 40 degrees Celsius, and the new density is rho. I hope you can remember the equation relating rho and rho naught. It is given by rho equals rho naught over 1 plus gamma delta theta. Okay, right. What is the meaning of fractional change? Fractional change. Now, fractional change means fractional change that will be equal to change divided by initial value. Change divided by initial value. Change divided by initial value. So what is the change? Change is rho minus rho naught, correct? Over initial value is rho naught. So what we need is rho over rho naught minus 1. Do you agree with me or not? This is the definition for fractional change. So from this, I think we can find out rho over rho naught, that is 1 over 1 plus gamma delta theta. So rho over rho naught is equal to 1 over 1 plus, what is gamma? 5 into 10 to the power minus 4. And what is delta theta? Delta theta is 20. So that is 1 over 100, 1.01, correct? 1 over 1.01. Right, 1 over 1.01. Okay. Now they are asking for the fractional change. Fractional change means fractional change in density. Correct, no people? Yeah, this is the equation. Change divided by initial density. So from final density, you are subtract the initial density. You need to divide by this. Okay. Now let's get the answer quickly. So rho over rho naught. What is rho over rho naught? It is 1 over 1 over 1.01 minus 1. If I take LCM, I'm getting 1 minus 1.01 over 1.01. So what is the answer? Minus 0.01 over 1.01, that is 1 over 101 people. What is 1 over 101? 1 over 101, that is very close to 0.01, correct? 0.01 should be 0.009, something like that, but I think we can settle this answer. I'm getting third one. Anyone else who got the third answer? Or if you have any other answers, we can discuss. Fractional change means change divided by initial value. Change divided by initial value. So it's rho minus rho naught over initial. Yeah. So I have divided each by rho naught, over rho naught minus 1. Rho O is equal to rho naught over 1 plus gamma delta T. So rho naught is this. Okay. Then 13th one. A convex lens of focal length 9 cm is placed between a luminous object and a screen which are 48 centimeters apart. An image can be seen on the screen when the object length is. All right, let me check it out. I'm sorry. Okay. Right, next question. But before we go to the next one, let's separate the territory for this. So this is the explanation for question number 12. Done. Now question number 13. A focal length, convex lens has a focal length of 9 centimeter. For this question, f is given as 9 centimeter. Right. So the object is here, and the lens is here, and the screen is here, and the length between this is 48 centimeter. Yeah. An image can be seen on the screen when the object length is right. So if I take the object length as x, oh yeah, maybe x, u is equal to x. What is the image distance, people? Image distance is going to be equal to 48 minus x, correct? It's going to be 48 minus x, because this is the image distance and this is the object distance, and the total is 48, because we will be getting the image on the screen, and the focal length is given as 9 centimeters. So we can apply the lens formula, and I put lens formula 1 over v minus 1 over u equals 1 over f. For 1 over v, we have to put 1 over minus 48 minus x, because it is measured on the right side, minus 1 over x equal to 1 over minus 9. All right. Okay, then we can multiply everything by minus. When I multiply everything by minus 1, it will give me 1 over 48 minus x. 1 over 48 minus x plus 1 over x equal to 1 over 9. I think we can take LCM here. It will be 48 minus x into x, and on top x plus 48 minus x, and that is equal to 1 over 9. Then I'm getting 48 into 9, that is equal to 48x minus x squared. So x squared minus 48x plus 48 into 9, that is equal to 0. Okay, what is the plan here, people? So we have to get it through addition. 48 into 9, 48 into 9, 24 into 18. 24 into 18. Can it be 36 into 12? No, 36 into 12. Is it possible? Yeah, 36 into 12 is possible. No? So what I have to do is I have to solve this quadratic equation. 48 into 9 is equal to how much? 48 into 9 is equal to 432. So 432 we can write 2 into 216, 4 into 54, 6 into 27, correct? So still it is 33. Then If I multiply this by 2, no. Okay, can you write it some other way, view? 6 into 42. I think we should be able to write it as 16 into 32. Is it possible? Check, will you? Yeah, 16 into 32. 16 into 30, 480. Yeah, 16 into 32 should be okay. No, wait. 16 into 32. Divide this by 3. Multiply this by 3. Okay, 320 plus 192. Shimra, we're not getting that number, Shimra. 12 into 32. 12 into 36. Sorry, 12 into 36. No, sorry. 12 into 36. Yes. 12 into 36. 12 into 36. 12 into 36. This is wrong. 12 into 36 will work. Yeah, 12 into 36 is correct. Correct. Yes, 12 into 36. 12 into 36 is also correct. So x squared minus 12x minus 36x plus 432, that is equal to 0. So x minus 12 minus 36, x minus 12 equal to 0. So x minus 12 and x minus 36 equal to 0. X could be 12 centimeter or x could be 36 centimeter. Do they have both the answers or one? Yeah. Fifth one is correct because you can keep it at 12 or 36. For both, it's correct because there will be two object distances and two object distances where you will be able to get the image. Fifth is the answer. Yes. I hope you guys understood that. I think I made a mistake here. Sorry about it. Sorry. I made a mistake here while I was writing something stupid, right? 4 into 108. 4 into 108. And then you multiply this by 3, divide. Okay, right. That is enough. Okay, people. How many of you got this answer? There will be two options. There will be two options. When you have kept the object at 12, also you will get the image at on the screen. When the object distance is 36, also you will be getting the image. 14th one. A graph A shows the vibration pattern emitted in a song. When a change was made to the sound in two occasions, the variation is shown by B and C. The property of sound which changed in the voice of the singer is. Right. I think now two changes they have given. I can see the frequency has changed, right? Frequency has changed. And here the amplitude has changed. So in this change in frequency. Because here for one wave for two boxes, here one wave for three boxes. So frequency, change in frequency, if not frequency has reduced actually. Change in frequency. So change in pitch. Change in pitch. And in C, what is happening? Change in amplitude. Change in amplitude. So change in who? Change in loudness. No change in quality because the wave pattern hasn't changed much. So I'm getting third one. Correct me, third one. Pitch and loudness. If there's a change in quality, the wave pattern won't be like this. The wave pattern will change. But it's the same wave pattern, a sine wave. Right. So that's the answer. Right. So next one, which of the following best represent the variation between kinetic energy and time of a body performing simple harmonic motion? The displacement measured from the midpoint when time is equal to 0. So wait, for this the answer was saying this is definitely wrong. Which answers are definitely wrong without even worrying? I can say 4 and 5 are wrong. Why? In these two, kinetic energy is a scalar. Kinetic energy is a scalar, so cannot have negative. So cannot have negative. And obviously the graph is going to be first. No, people. Obviously the graph is going to be the first one. I'll tell you the reason. These are wrong. The reason is this now. Your oscillation is starting in the middle. Oscillation, they have said the oscillation is starting in the middle. So in the middle means x is 0. When time is equal to 0, velocity is maximum. If velocity is maximum, kinetic energy is also maximum. So this is that's why this is wrong. That's why this is wrong. The variation of what? This is the variation of speed. This is the variation of speed, not kinetic energy. Kinetic energy will vary like this. It will not be a smooth like this. It will go like this. So answer should be first one. Okay, kinetic energy and potential energy graphs will be like this. And I don't think this is necessary. I mean, I'll just draw the graphs. If you draw the graph for displacement with time, x displacement with time, and if the graph is like this, and when you draw the graph for velocity with time, your graph will be like this. Graph of velocity will be like this, right? And the graph for acceleration, if they ask in future, how will it be? It will be exactly, it will be similar to displacement, but negative of that, because a is equal to minus omega squared x, so something like this. On the other hand, if you draw the graph for kinetic energy, it will not have negative signs. It will look like this, right? These are the reference points now, 1 2 3 4. It will not be exactly as same as velocity. It will go like this. That's how this is how it's going to be. Understood? This is how it's going to be. So that's why we went with 1. Fourth is wrong. It can't have negative. And right, just adding one more. If they ask for potential energy graph, the potential energy graph will be the mirror image of kinetic energy graph. Not mirror image. Wait, it will be like this. Wherever kinetic energy is 0, potential energy will be maximum. Wherever potential energy is 0, kinetic energy will be maximum. Sorry. Like this. This is how the potential energy graph is going to be. I mean, okay, right. And if you draw these two also up, it will be speed. This is velocity v. 16th one. An object of density rho, I think, no? Rho, oh no, P floats on in a liquid of density P naught. What fraction of total volume of the object is above the liquid level? Might be difficult. 16th one. This is the liquid and the object is like this. Fraction of total volume. So A of the object is above the liquid. So let's say this is the volume they're asking us to people. Volume above. We'll put it that way. Okay. And what is the submerged volume then? Submerged volume will be equal to total volume minus volume above. We'll take it that way. And we know in G is there, that should be equal to upthrust according to principle of flotation. If I write the equations, upthrust is equal to mg, and upthrust is going to be the submerged volume density of the liquid g, and this one is going to be the total volume and the density of the object g. That means we are able to cancel out simple g, and now it's time to quickly substitute the values carefully. The submerged volume should be total volume minus the volume of the object above equal to the total volume is the total volume. Oh wait, into, I forgot to put the density, into density of the liquid P naught equal to total volume. Okay, total volume into density of the object P. The question is, what fraction of total volume of the object is above the liquid level? They are asking us to find out volume of the object above liquid level over total volume. That's what we have to find out, correct? That's what we have to find out. So let's try to find that out. I'm getting total volume minus volume of above divided by total volume, that is equal to P over P naught. And we can divide them 1 minus the ratio we are looking for, V above or V total. Answer V above over V total, I'm getting that is equal to 1 minus P over P naught. I think it should be P naught minus P over P naught. I'm getting the third answer, people. Anyone else? Okay, good. Hasna, what is your answer? First one. You got the first one. That's all. Shimra, what about you? Shimra, Zainab, Fahim? Hamda? What happened? Zainab, Tawfiq? No. They are asking for the volume of the object above. I don't know whether you found the volume of the object submerged volume. Okay, right, good. Third is the answer. Huh? Just double checking with you, right? 17th one. 20 watt electric heat is used to raise the temperature of water of mass 0.1 kilogram at constant rate of 30 degrees Celsius per minute. Heat loss to the surrounding and heat capacity of the container are negligible. Specific heat capacity of the liquid is yeah, should be a very easy question. 17th one. What is it? 17th. The question is this. 17th. We know Q equals mc delta theta, but when I put dq by dt here, dq by dt, that's equal to mc d theta by dt. We have divided either side by time. Now dq by dt is 20, mass 0.1, specific heat capacity we have to find out. D theta by dt is 30 degrees Celsius per minute, so it should be 30 over 60. 30 over 60 degrees Celsius per seconds. Okay, here we in this question means d theta over dt, they have got 30 degrees Celsius 30 degrees Celsius per minute. That means in 1 minute 30 degrees Celsius it's going to increase. So in 1 second 30 over 60 degrees Celsius per second. Every second actually half degree Celsius should increase. In 1 minute, if 30 degrees Celsius are increasing, in 1 second, half degree Celsius should increase. No? So what kind of answer they are expecting? C, I'm getting it's equal to 20 into 60 over 0.1 into 30. Have they given an answer like this? Have they? No. Yeah, fifth answer. No, not fifth answer. What's going on? 20 into 60 over. Did you people get an answer for this question? There was no answer, no? Oh, yeah. Fifth one looks like the closest one, fifth one, because only in the fifth one we have 20 and 60 on top. Only the fifth one we have 20 and 60 on the top. So let's make a small change to that answer and let's choose that as the answer. We'll put a 0 here. So I'll go with fifth one. Right, because that is the only answer which has is 20 and into 60 up. So I'll go with this. Right? Fine. Question number 18. If the percentage change in length of a metal rod when heated from 0 degrees Celsius to 100 degrees Celsius is 0.02 percentage, the linear expansivity of the metal. Right, that should be a very simple question. 18th one, we can use this equation. 18th one, delta L is equal to L naught alpha theta. So delta L over L naught is equal to alpha theta. Percentage change, right? Percentage change in length means percentage change in length is equal to delta L over L naught into 100, and that is 100 alpha theta. So I have to multiply either side by 100, people. It is 100 alpha theta. So this value is given to us. It is 0.02. This whole thing 0.02. This is the percentage change in length, and that is 0.02 equals to 100 times alpha. We have to find out. Theta is the temperature difference. What's the temperature difference, people? 0 to 100, that is 100. So I'm getting alpha is equal to 0.02 over 10 to the power 4, and is that 2 into 10 to the power 6 minus 6 per degree Celsius? Yeah. Is that okay? Second one looks like the answer. I'm getting second. Hope you also got the second one. Yep, cool. Right, moving on. Which of the following graphs best represent the variation of the object length and image length of an object which is placed in front of a convex lens? Graph for 1 over V over 1 over U. 1 over O, 1 over U. I don't think it's it should be a straight line graph, no people. It should be a straight line graph. The reason is you have an object in front of a convex lens. You have an object in front of a convex lens. So f is going to be a negative value, and you have your object is here, and you have a u here. This way, it's positive. Now v can be negative or positive. 1 over v minus 1 over u equal to 1 over f. If I make 1 over v the subject, 1 over v is equal to 1 over u plus 1 over f. And there's only one option we have, right? I mean, I think we have to put the sign, they have put the sign convention, I think, for f. So 1 over v minus 1 over u equal to 1 over minus f. So 1 over v equals 1 over u plus, minus 1 over f. I can write 1 over v equal to 1 into 1 over u minus 1 over f. This looks like This looks like y equals mx minus c, where this will be in y-axis, this will be in x-axis, and you will have a negative intercept. So there's only one for a proper answer, second one. Sure, sir, should not we multiply both sides by 100? Yeah, multiply both sides by 100, no? Here. Now wait, yeah, this confusion can happen. Wait a minute. And it's like this now. I'm trying. It's like this. Listen, this question now. We know delta L is equal to L naught or L naught alpha delta. Wait, what is the percentage change in length? Percentage change in length. What is the equation? Percentage change in length. The equation is going to be change in length over initial length into 100. Right? Okay. Percentage change in length is 0.25 given to us. 0.02, sorry, 0.02 equal to, instead of this one, delta L over L naught, I'm going to use an equation like this. Delta L is equal to L naught alpha theta. So delta L over L naught is equal to alpha theta. Then what I'm going to do is instead of delta L over L naught, I'm going to bring alpha theta into 100. Okay, so 0.02 equals alpha, we have to find out theta is 100 into 100. Okay now, alpha is equal to 0.2 over 10 to the power 4. 0.02 actually, 0.02 over 10 to 0.02 over 10 to the power 4, and the answer is 2 into 10 to the power minus 6. I hope now it makes sense. You don't have to multiply both sides. Careful. Right. And here there's only one answer with y equal mx minus c. Which one is that? Second one, right? Second one. Because this graph is y equal mx minus c format. Okay. Sorry, wait. Okay, well, this is it. So this is the answer. Done. Then we'll move on because you have to be careful. The axis is 1 over v over 1 over v and 1 over u. So it's not v and u. We are focusing on the 20th MCQ. A wooden cube of side length 10 centimeter floats in water immersed 8 centimeters. Minimum force, minimum work to be done in order to keep the cube fully immersed in water. Okay, fully immersed in water. Right, let's get started here. Work needed, right? Minimum force needed, yeah. 10 centimeter. A wooden cube of side length 10 centimeter floats in a height of 8 centimeter. So this diagram very correct, no? Because height itself is 10 centimeter. Cube of side length 10 centimeter floating water immersed a height of 8 centimeter as shown in the figure. The minimum force and the minimum to be done. I think this diagram might be a little bit misleading. Make a quick change here. Right, question number 20. A wooden cube of side 10 centimeters floats on water. Floats on water immersed to a height of 8 centimeters as shown in the figure. So 8 centimeters is in underwater. That means 2 centimeters is going to be above water. I was telling before the connection was lost, this is not this diagram could be a little misleading. So let's change it a little bit because more of the wooden block should be inside water. Therefore, I'll mark it this way. Now okay, now better. This is the water level, and let's take this height as 8 centimeters. This is 8 centimeters, so 2 centimeters outside, like this. 2 centimeters outside. The minimum force and the minimum work to be done in order to keep the cube fully immersed in water. So here we have weight and upthrust acting on it, and if it completely submerges, what will happen? Now I say it completely submerges. I'll just draw the side view. If it completely submerges, all 10 centimeter will be inside water, and we can't just have it we can't just have mg and the upthrust as the forces. There will be another force acting. What is that? That is the force we apply from outside. And applied force from outside, we'll take it as F. So the applied force F is equal to what? What is the applied force F, people? Applied force F, that is equal to change in upthrust. Change in upthrust. Because weight is not going to go anywhere. So upthrust is going to increase. That increment in upthrust is due to that force F. So F is equal to change in upthrust is going to be change in the submerged volume, density of the liquid into G. Okay. So change in the submerged volume will be 2 centimeter is additionally submerged. 2 centimeter is additionally submerged into the. I'll write it this way. Change in length, cross sectional area, density of the liquid into G. Change in length is 2 centimeters, and the cross section area is 10 over 100 into 10 over 100, because it is, what is it? It is a cube. So at the bottom, all the size will be 10 centimeters and 10 centimeters. And 10 centimeters this way. Right, and into density of water is 1000 into G. Therefore, all the zeros on top, 6 zeros on top, 6 zeros at the bottom, it will be 2 Newton. Answer is 2 Newton. Yes, I saw 2 Newton there. So these answers are wrong. What is the additional work needs to be done, people? What is the additional work needs to be done? Tell you. Additional work we need to do, that will be what? We are reducing the gravitational potential energy. We are reducing the gravitational potential energy is reduced. Then what is the work done? Work done should be force into distance, no? Force into distance, but we have to be a little careful. When I say force, upthrust is also there. Don't forget that. Upthrust is there, but should we worry about the upthrust? Initial weight is equal to upthrust. Now the new upthrust is 1.25. 0.25 minus u is 0.25. Okay, let's finish this off with now work done. Sorry, work done is going to be equal to work done, that is equal to force into distance. What is the force applied? We are applying a force of 2 Newton. 2 into the distance traveled, how much? 2 into the distance travel will be 2 centimeters. 2 over 100. Therefore, 0.04 joules, is it? 0.04 joules. The problem is the weight and upthrust are there. Upthrust is going to change. No? Upthrust is going to increase. So force is going to increase by 2 Newton. Minimum force and the minimum work to be done. Minimum force and the minimum work to be done. Wait a minute. Sorry. Okay, yeah, that is the answer. Right, fine. That's a minimum force, and you'll get this answer. Right, second one. 11th one. 21. Sorry. Starting from rest, a ceiling fan rotates about its axis 3 rounds in the first second under constant angular acceleration. Number of rounds then it completes during the 4th second would be. Wow, interesting. Starting from rest. So 21st question. 21st one. 4th second. Now this one we discussed based on motion under gravity as well. Now when an object rotates with when an object, listen to me carefully, when an object rotates with constant angular acceleration, constant angular acceleration starting from rest, acceleration starting from rest, you can use this equation. Theta is equal to omega naught t plus half alpha t squared, but we know omega naught is 0, people, but omega naught is 0. So equation for theta, it's going to be equal to half, if not alpha t squared by 2, alpha t squared by 2. So when t is equal to 1 when t is equal to 1 second, theta is equal to alpha by 2, and the alpha by 2 is given as 3, correct? Alpha by 2 into 1 square, and that is equal to 3 according to the question. 3 rounds, 3 rounds, 3 rounds. I'll just put 3 revs. So 3 rounds. Therefore, alpha is equal to what? 6 revolutions second minus 2, something like that. Not radian second minus 6 revolutions second minus 2. That is our alpha. The question is number of rounds then it completes during 4th second. So when time is equal to 3 seconds, theta is equal to alpha by 2 into 3 squared, that is how much? 3 square, that is going to be 9 alpha by 2. Okay, when t is equal to 4 seconds, theta is equal to what? Alpha by 2 into 4 squared, that is going to be equal to 16 alpha by 2. I'll leave that 2 at the bottom. So question is rotation in number of theta in 4th second. Theta in 4th second, that will be theta after 4 seconds minus theta after 3 seconds, this. So that is, I think, 7 alpha by 2. Instead of alpha, we can put 6. So 7 into 6 by 2, I'm getting an answer 21. Anyone else who got that answer? 21 revolutions. Good. 21 is the answer. And this is how you have to do it. When you want to find out the displacement in the 4th second, what do you have to do? You have to find the displacement after 4 seconds. You have to find the displacement after 3 seconds, subtract. And in the 1st second, it rotates 3 rounds. From using that, I found alpha, that is 6 revolutions in second minus 2. Then I substitute that here and getting the answer. Right. Now 22nd one. The fundamental frequency produced by certain tube closed at one end is 512 hertz. If the tube is open at both ends, fundamental frequency will be. So we can go for direct equation, right? So you can go for direct equations. Yes, you can go for direct equations, no problem. 22. What about 22? We take 22. When the tube is closed, it's like this, and the length is L. And the frequency, fundamental frequency is 512 hertz. Yes. So speed of sound in air will not change. Now speed of sound in air will not change, right? Now here we have lambda by 4 is equal to L. Now people, lambda by 4 is equal to L. Lambda by 4 is equal to L. The length of the tube doesn't change, so you can say lambda is equal to 4L. Lambda is equal to 4L, right? So for this scenario, when you apply V equal F lambda, V is equal to 512 into 4L. I will leave it that way. Now we are opening both the ends. And now there will be a new what frequency? I'll take this F naught and lambda naught here. Now I say the new fundamental frequency is F1, and now the length is L. The length of the tube doesn't change, no people. Now lambda 1 by 2 is only L. That means lambda 1 is equal to 2L. Correct? Lambda 1 is equal to 2L. Now let's put V equal F lambda. When you put V equal F lambda, instead of V, we can substitute this value. Which value? The earlier value we found, 512 into 4L equal to the new frequency is F1, and in the new wavelength lambda 1 is 2L. Yes. So what is F1? F1 is equal to 2L and 4L. You can simplify, and there will be a 2 here. 1024 hertz. I'm getting 1024 hertz. Anyone else? I'm getting the fifth answer. If you got the answer, can you see? Give me a raise of hands, please. Oh, good. Right. 1024. Good. 23rd one. The sum of apparent frequencies heard by an observer. The sum of apparent frequencies heard by an observer who moves at the same constant velocity towards and away from a stationary stationary object is 720 hertz. The actual frequency of sound wave produced by the source is good. This is to the 20. This is the 23rd question. Right. So let's analyze the 23rd question. Right. So this person is moving towards and away. When the source is, this is the source, and it has an original frequency f naught. We don't know what that is. We have to find that. Vs is 0. It's stationary. So first of all, the observer is moving towards, what is the speed? Constant velocity. They're saying it's just they're just mentioning constant velocity. If you say constant velocity, that means we'll take it as I don't know, what is it, VO, right? He's moving at VO, and this time he's hearing a sound of F1, let's say. The sum of apparent frequencies, the sum, nice, F1, and then he's moving away. He's moving away, and he's hearing F2 when he's moving away from the source, which is at stationary and has a original frequency of F0. So what is F1? F1 is equal to C plus VO over C into F0, and F2 is equal to C minus V over C into F0. Then this is equation 1 and equation 2. Let's add them both. 1 plus 2. On the left side it is F1 plus F2. On the right side, people, F0 over C, it's common, and inside the bracket I'm getting C plus VO plus C minus VO. Okay, F1 plus F2, the sum is given as 720. That is given in the mentioned in the question. If you look at that carefully, 720, and FO will be there outside, no change. FO over C into, here it is 2C, correct, 2C, because this V0 and minus V0, they will get cancelled out. And here C and C will get cancelled out. Therefore, I'm getting F0. F0, 2 F0 is equal to 720. So what is F0, people? F0, I'm getting 360 hertz, correct? So the answer is second. Anyone else who got second? Raise of hands quickly. Right. Right, next question. A point source of light O situated at the bottom of a water tank emits a ray of light as shown in the figure. The tank is placed on a smooth horizontal surface. The maximum horizontal acceleration of the tank so that the emergent ray of light just enter the water air interface would be. Interesting question. NW is 4 by 3. Emergent ray of light just enter the water air interface. So I think we are looking for a scenario like this. We want this to happen. I mean, we want that ray to undergo total critical refraction. Na, people? We want the ray to undergo critical refraction. That means the water level should become like this. Water level has to become like this. So the ray of light, I'll go with orange color or something. The ray of light comes like this. and then the angle it creates with the what do you call that angle it creates with the normal, that is the angle of incidence now. So that angle now has to be critical angle. That's the question. The angle has to be critical angle here. So mark it. Then only this will happen. They want this to happen. They want the ray to go this way, grazing the water surface. That's what they're saying, right? They want ray to come back to water like this. And if for that to happen, this angle has to be what? This angle has to be critical angle. Okay, that angle has to be critical angle. If that angle is critical angle, what is this angle? What is this angle, people? Anyone? This angle is also critical angle, no? Do you agree? This angle is also critical angle. Yes. This angle has to be critical angle. The angle I have marked here because if I complete this, now this is C, that means this small angle here I am marking, what is it? That is going to be 90 minus C. Do you agree with me? 90 minus C. Because from the normal C, this is 90 minus C. This angle is also C. This angle I marked here is also C. Because 90 minus C, 90. So this is also C. Right. Now we know whenever we have a situation like this will happen if you have an acceleration in this direction. People, wait a minute, I think this diagram is a little too small, so the angles and all are not very clear. Let me quickly draw the diagram again, but I want to draw it a little larger now. Give me a second. Draw a larger tank like this and cover the top part with white, covered, and we want this to happen, and then that happens, we want the ray to graze the surface. We want the ray to graze the surface like this. And during that time, right, okay, this one, and we have C. This is C now, people. This angle has to be C, the critical angle, so that this will be 90. So if that is C, if I take this angle is 90 minus C. Agreed? This angle is 90 minus C because this whole thing is 90, right? 90 minus C. So this angle is also C. This angle is C. Now I think it's better. And for something like this to take place, we know the beaker should accelerate in this direction. This is there in many past papers, people. We have an equation for this now. If I take this length as L and if I take this height as H, what is the relationship should be between A, H and L? Can anyone remember? There's an equation which connects those things. What is that equation, people? The equation is what? A over G, okay, A over G, that's equal to H over L, correct? A over G is equal to H over L. I can derive it, but it might take time. It comes from that pressure equation. I mean, how many of you want me to derive it? I hope it's not necessary. Just remember this hereafter. In future, for your future questions, it would be better if you can remember it. I mean, H is the height difference between the water levels on the right corner and the left corner, H, and you divide it by the width, and that will give you the ratio between the acceleration of the beaker and the gravitational acceleration, A, right? So the question is A, you have to find A. So A is equal to G into, what is H over L? That is tan C, correct? H over L, that is the height difference, and the width is tan C, opposite over adjacent, tan C. But we know there's an equation for C. What is the equation for C? We tan C, just C. But we know sine C is equal to 1 over n, where because C is the critical angle. So C is sine inverse 1 over n, the angle. Therefore, if I substitute that properly, A will be equal to G times tan, inside tan I have to put C, instead of that I can put sine inverse 1 over n. That's why we have an answer like this. Okay, so what is the answer? I think it should be second one, no people? Second one. So how do we identify that acceleration is towards left side? I mean, it's like this. If you want this part, if you want the right side to be lifted up, here we have high pressure, here we have low pressure. So from high pressure to low pressure, force. From high pressure to low pressure, force. Correct? So that the direction of force, there must be the direction of acceleration too. Is that clear? The side to the side where it's elevated, here we have high pressure, low pressure. From high pressure to low pressure only force will act. So that direction we will have the acceleration to. Answer is second one. How many of you got the second answer? Can I see a raise of hands? No. Okay, never mind. It's a good question, people. A very rare one. I have not seen this before. So combining this and this, so you should need to remember this equation. If you can't remember that equation, then it will be a problem. Next, 25. A uniform glass cylinder of length 1 meter and cross-sectional area 10 centimeters squared contains air at atmospheric pressure 76 centimeter mercury. Find the force applied on the closed end of the cylinder vertical down into a mercury bath so that mercury rises up to 1/5 of volume of the cylinder. Interesting. We need we need the system to change like this. No? That's what they asking it. Okay, let's see if you can figure this out. We want it to immerse 1/5 of its initial volume, right? This way. Okay, so what law are you going to use here, people? Here we have V, the volume here, V1. I'll take the volume V1 here, it's V. Now the new volume is 4V by 5. Do you agree with me? 4V by 5. 1/5 of the volume vertically down into mercury bath so that mercury rises up to 1/5 of the volume of the cylinder. So 4V by 5 is the volume of air. So what law should we use here? I think we can use Boyle's law, right? Boyle's law. So we'll take the pressure here as P1, atmospheric pressure, and here the pressure is P2. For these two scenarios, I think we can apply Boyle's law. P1 V1 equals P2 V2. What is P1? P1 is 76 centimeter mercury. Should I use that value? Okay, because the answer is in Newton and all. I don't mind. We'll take 76 centimeter mercury into V1 is V. P2 is P2, we don't know, into the new volume is 4V by 5. Right? So what is P2 now, people? P2 is equal to 5 into 76 over 4. I think we can divide 76 by 4 and it's 19. 19 into 5 is 95 centimeter mercury. Mercury centimeter, 95. That is the new pressure. So the pressure, additional pressure is how much? So increase in pressure. So increase in pressure. So increase in pressure, that is equal to 95 mercury centimeter minus 76 mercury centimeter. What is the value? That is going to be 19 mercury centimeter. 19 mercury centimeter. So we are supposed to find out the force exerted, no? Find the force applied. So this the increase in that pressure happened due to the force we apply. We are applying a force here. We are applying a force due to that force only, that increase in pressure happened. So what is the equation for force then? Change in pressure. Change in pressure, that is equal to force over area. Correct? Change in pressure is equal to force over area. That means force is equal to change in pressure into area, but the answer is in newtons. So force is equal to change in pressure is 19 centimeter mercury multiplied by area. What is the area, people? 10 meter squared. So that is 10 centimeter squared, 10 into 10 to the power minus 4. Tell me, 19 centimeter mercury, how will you convert it to Pascal? Because this is in meter square now, we have to convert it into newtons per meter square. So I have to convert it to Pascal. What I can do is I can first convert it to meters and then multiply by the density of mercury and then multiplied by 10. Because when you say pressure is equal to 19 centimeter mercury, pressure is equal to H rho G. This is pressure in terms of mercury column people. So for height you put 19 over 100 meters. For density of mercury you put 13,600 and G10. That's how this came. Into 10 into 10 to the power minus 4. So people, what do you think is the answer? Interesting. Fourth one. Oh yeah, fourth one. Are you getting 27.2 exactly or 7? I got 95 minus 76. Is it 96? No. It's 95. Almost, I think. Yeah, okay. Force is equal to 19 into 136. When you multiply 136 by 19, what do we get? 4, 5 balance, 2, 3 balance, 12, 6, 3, 1. 8, 5, 3. I'm getting something like this. 2. Sorry, 2. I'm getting an answer like that, November. 100. So I'm getting 25.85. So the closest answer is 27.2, no? I think they have taken this as 96 mercury, centimeter mercury, somehow. This has become 96. I don't know how it became 96. Fine then, the closest answer we have is the fourth one, so I'll go with the fourth. Chimra, how did you get the fourth one? Did you exactly get the fourth one? Or am I missing something here? Or else did you convert this by dividing it by 76 into, you did something like that? The unit conversion. So you got the length as 20 centimeter. You got the length as 20 centimeter. What is the length? You got the length as 20. How is that possible? 20 centimeter. You got the length as 20 centimeter. How is that? But that is the answer. Fourth one should be the answer. But how did she get 20? 95 minus 76 is 19. I mean, am I missing something here? If not, how did you do it? Tell me. Can you unmute and explain? They have given the length of the tube as 1 meter. Oh, is it? Right. Okay. They have given the length of the tube as 1 meter, cross section area this, okay, fine. But still, will it make a big change, difference? Length is 80 here now, length is 80. So change in length is 20. (96). Ah, you have taken it that way without applying Boyle's law. But what's wrong in applying Boyle's law? Fine. Okay, wait. Yes. We can do it this way. There's another way of doing it. That is this, people. Look at the screen. Wait. Okay. Find the force applied close to vertical down into. Find the force applied to the on the closed end of the cylinder vertically down into mercury bar, so that mercury rises up 1/5 of volume of the cylinder. I think this is how you have done it. I mean, I'll just explain it. Another way of finding this pressure inside looks like they have done it this way. Consider that the increment in mercury is because of additional force given. Additional force given. Right. Okay. See if you can understand this explanation, people. This is fine. And then now, P1 is 76 centimeter mercury. Now, once you do that, wait. I think I'll save this and move on to a fresh slide. Otherwise, it will be a problem. Right, we are done with the previous one. Okay. Sorry, time's up. Because the answer is that answer I got is not there. That's the issue. But now I got a different idea. See if this works. And that is this. But the problem is we need the mercury to rise into the tube. Mercury to rise into the tube. So something like this happens. Tube doesn't get immersed, but mercury gets into the tube like this, 1/5. Okay. Mercury gets into 1/5 of the tube, something like this. If you do it that way, I think you will be able to get that particular answer they have given. Because now here the pressure is P1 here. Pressure is P1. The new pressure is P2. All right. But this point and this point should have the same pressure. No, people. Pressure at A and pressure at B should be equal. No. And this height. What is this length? No. This length is how much? This length is 20 centimeters. 20 centimeters. Because this total length is 100 centimeter. 1/5 is submerged. Right. So I can say pressure at A is equal to pressure at B. Pressure at A is P2 plus H rho G equal to PB. PB is the atmospheric pressure. So P2, the new pressure we don't know, plus H rho G. Instead of H rho G, I can put 20 centimeter mercury. 20 centimeter mercury equal to ATM. Atmospheric pressure is 76. No, it doesn't work that way, no? Then this reduces, no, people. Then will it's 56. P2 is 56. Okay. Okay, that we'll see. So this is 76 centimeter mercury. So I'm getting P2 plus H rho G is 20 centimeter mercury equal to 76 centimeter mercury. So the new pressure is 56 centimeter mercury. Correct? 56 centimeter mercury. So change in pressure. Change in pressure is going to be equal to initial pressure is P1. Now the final P1 minus P2. P1 is 76, P2 is 56. So you are getting 20 centimeter mercury, is it? So change in pressure is equal to force. Force needed is equal to change in pressure into area. Change in pressure is equal to 20 centimeter mercury into area. Area is 10 centimeter square, 10 into 10 power minus 4. So force is equal to 20 over 100. I'm converting centimeter mercury to Pascal. I need to multiply that by 13,600 and then again 10 into 10 to the power 10 into 10 to the power minus 4. Okay, I think now if you multiply this whole thing, you will be getting 27 by 2. Is this how you did, Shimra? This doesn't make sense now. How can it happen this way? This is how you are getting that exact answer. Which answer? Fourth one. But how? Fine. Okay, there are two things. Just have a look at the previous one. Looked convincing to me, but the problem is we are not getting this exact same answer. That's the issue. Right, let's see. Still we are halfway through, people. 2 moles of an ideal gas is trapped in a cylinder using a frictionless piston at constant temperature T. When the temperature is increased while keeping the pressure constant, volume of the gas is doubled. Work done by the gas in increasing the volume is. The temperature is increased while keeping the pressure constant. Volume of the gas is doubled. Work done by the gas in increasing the volume is. 2 moles of an ideal gas is trapped in a cylinder using a frictionless piston at a constant temperature. When the temperature is increased while keeping pressure constant, volume of the gas is doubled. Right. Let's see if we can figure this out. Figure the board. 26. Okay, 26. So you have a piston. Volume of the gas is doubled. So initially you have the piston somewhere here, where the volume is V, pressure is P, temperature T. Temperature T. Now what they're doing is they're doubling the volume. They're doubling the volume. So when they double the volume, pressure is still P. The volume is 2V now. Correct? Volume is 2V. Temperature we don't know. New temperature. Tell me now what is the equation for work done? Work done is equal to, okay, work done is equal to pressure into change in volume. Pressure into change in volume. So pressure into, what is change in volume, people, here happening here? 2V minus V. Initially it was V, finally it is 2V, so 2V minus V. Therefore work done is equal to PV. Work done is equal to PV. If they had said it's tripled, it will be 3V minus V. So here the volume was doubled now at constant pressure here, keeping pressure constant. Volume of the gas is doubled. So this is the equation. PV is the equation. Right, for this system, if I apply PV equal to nRT, I will be able to find a value for PV. Apply PV equal to nRT, right, on the left side PV, N is given as 2, I think, 2 into RT, therefore PV is equal to 2RT. PV is equal to 2RT, correct? For the first one, because we don't know the temperature of the second scenario, people. So tell me what is the equation? What is the equation? That is 2RT. Answer is fifth one. How many of you got fifth? Right, good. 26th done. Now we move on to 27th. When the pressure of an ideal gas is increased by 2% at isothermal condition, the percentage decrease in volume. Right, very interesting. People, what is the meaning of isothermal condition? Isothermal condition means who is constant? Isothermal condition means temperature is constant. Temperature constant. So when you say temperature is constant, you are getting the license to use who? Boyle's law. Boyle's law. Okay. When the pressure of an ideal gas is increased by 2% at an isothermal condition, the percentage decrease in volume. Right, interesting question. Let's focus on 27th here. Right, 27. People, initial pressure P1, P1 will take it as P, and initial volume V1 will take it as V. That is the first system. Now we have a system like this, and then they are increasing the pressure or something, and the volume is going to decrease. Right. So initial pressure will take it as P, initial volume will take it as V. Final pressure, what is the final pressure here, people? P2 is equal to volume, pressure is increased by 2%, that is 102 P over 100. Do you agree with me? 102 P over 100, because it's increased by 2%, and V2 we have to find out. V2 in the sense percentage decrease in volume. So percentage decrease in volume means what? Percentage decrease in volume means we need to find out change in volume, that is V1 minus V2, okay, V1 minus V2 over initial volume into 100. That is 1 minus V2 over V1 into 100, correct? So here you can put P1 V1 equals P2 V2. So I need the ratio V2 over V1 now, people, to finish this off. Then I will make that the subject V2 over V1, and that is going to be equal to P1 over P2. If not, we'll substitute the values. Sorry. P is P1 is P into V1 equal to P2 is 102 P over 100. Hope you can understand. 2% increase means you can write it this way into V2. So what we need in the question, if I finalize the question, is V2 over V1, right? V2 over V1 equal to pressure is going to get cancelled out here, pressure gone. It's 100 over 102. 100 over 102. Then if I finish this off, 1 minus 100 over 102 into 100. People, what is the answer we are going to get? 200 over 102. ఏం ఉత్తరం అన్నా మీకు? Percentage decrease in volume. Pressure is increasing by 2%. Isothermal condition means it's Boyle's law. So this is the equation. 1.9. Yeah, that's the problem. We will be getting 1.9. That's reasonable. Because if I simplify this one, I'm going to get 2 over 102 into 100. That is 200 over 102. 200 over 102 can be roughly say it's equal to 2%. Let's settle it down. No? That is the answer. Answer should be very close to 2%. This is the answer, people. So percentage decrease in volume means initial volume minus final volume over initial volume. That is 1 minus V2 by V1 into 100. 1 minus V2 over V1, we found it using Boyle's law. V2 over V1 is going to be 100 over 102. So if I take 102 as the LCM, it's 102 minus 102 divided by 100. So I think we should go to second answer. How many of you got the second answer? Settle with second one. Okay, because the answer is very close to 1.9 something. 28. Two glass bulbs A and B of volumes 50 centimeter cube and 150 centimeter cube are connected by a narrow tube. Both bulbs contain the same ideal gas at temperature 100 Kelvin and 400 Kelvin respectively. The ratio mass of gas of bulb A over mass of gas of bulb B is given by. Oh, that's not a problem, I think. There are two bulbs. 28. 50 and 150. Okay. 50, 150. It's the same gas as well. So, okay. volume of A is equal to 50, volume of B is equal to 150. I'm going to for okay, this is centimeter cube, and the temperatures are also given. Temperature in A is equal to 100 Kelvin and temperature in B is equal to 400 Kelvin. By a narrow, are connected by a narrow tube. Oh, they are connected by a narrow tube. What is the meaning of that, people? If they are connected by a narrow tube, they both have something in common. Can someone tell me what that is? Two bulbs will have something in common. What is that, anyone? The two bulbs will have something in common. That will be the pressure. Correct. The pressures will be equal. Pressure 1 and here pressure 2. Pressure 1 and pressure 2 are going to be equal, and the mass we don't know. M1, M2. We have to find the ratio between. Oh no, wait. We'll put it as PA, PB. Pressure of bulb A, pressure of bulb B, and mass of gas in A, mass of gas in B. So we have to find MAO, MB. For that, what is the plan? Right. First thing we know is PV equal to, when you write PV equal to nRT, make pressure the subject. PV equal to nRT. Sorry, PV equal to nRT. P is PV. It's equal to simple MO capital M RT. So P can be written as MRT over capital MV. But in this one, I can say pressure is proportional to MT over V. Can you tell me why that is? Because R, capital M, they are constants. It's the same gas in both the bulbs, and R is anyway a constant. Therefore, capital M and R can be taken as constant. This P proportional to PMO. If not, wait. We'll not make it complicated unnecessarily. We'll leave it like that. Okay. Since the bulbs are connected by a narrow tube, we know pressure in A is equal to pressure in B, people. So pressure in A is equal to mass of A into R into T. Temperature is 100 over molar mass is capital M and the volume is 50. I can just substitute the values as it is, because on either side we will get we are substituting the same unit, people. Here mass of B into R into 400 over capital M molar mass into 150. Therefore, you will end up in something like this: mass of gas in A, bulb A, or mass of gas in bulb B, that is equal to, let's cancel out the things we can cancel out. Capital M you can cancel out, capital R you can cancel out, these two zeros we can cancel out, and this 50 and this 150 we can cancel out, put a 3 here. So I have a 4 and a 3. That's all. Yeah, I have a 4 and a 3. So 4 by 3. 4 by 3. I'm getting 4 by 3. Anyone else who got the answer? 4 by 3. Yeah, it's pretty simple and straightforward. Fifth one. Okay. So the important part is PA equals to PB. Why is that? PA equals PB because bulbs are connected by narrow tube. If the bulbs are connected by narrow tube, the gas molecules will move and settle down when the two pressures are equal. Right, the next one, 29th. Two containers contain two ideal gases at same pressure. D1 and D2 are the densities of the two gases. The ratio of mean square speed of them. So hope you can remember mean ratio of mean square velocity. Yeah. So mean square velocity is c squared bar. C squared bar, we all know the equation for that is 3RT over M. That is the most commonly used equation. But that can also be written as 3P over D. 3P over D. You can also write it as 3P over 3 into pressure over density. If you want me to explain how that happens, we know PV is equal to nRT, and then you can change it to PV equal to simple M over capital M RT, and then you can change it to P capital M over RT. It's equal to simple M over V, where simple M over V is our density. So instead of RT over capital M, you can write P over D. So I have proved it here for you in case if you are confused about how I wrote it. We use this concept in speed of gas in air. Also we use this concept also 3P over D, and they are saying they are maintained at same pressure or something, same pressure. So but pressure constant, but pressure constant, but pressure constant. If pressure is constant, what is going to be the equation? C squared bar is proportional to 1 over D. Okay, so C squared bar 1 is proportional to 1 over D1, C squared bar 2 is proportional to 1 over D2. Then they are asking for the ratio between the two gases, I think. Yes, yeah. Then C squared bar 1 over C squared bar 2, that is equal to, when I divide them, it's D2 over D1. No square root, no square root. Root means square velocity means you have to consider square root, but they have not mentioned anything like that. No? So the answer is fourth one, guys. Anyone who got the fourth one, please? Who got the fourth one? Oh, nice. If you have any problems, do ask, and hope right where I have. Okay, good. 30th one. A closed container of volume 500 centimeter cube, which is maintained at a constant temperature, contains water, vapor, and the relative humidity 30%. The absolute humidity is 30 gram per decimeter cube. When water vapor of mass 2.5 gram is inserted into the container, the new relative humidity would be. Okay, interesting. So let me focus on that. Question number 30. A closed container of volume 500 centimeter cube, which is maintained at a constant temperature, contains water vapor and the relative humidity 30%. Absolute humidity is given 30 gram per decimeter cube. When water vapor of mass 2.5 gram is inserted into the container, the new relative humidity would be. The absolute humidity is 30. The absolute humidity is 30 means. What is the equation for relative humidity, people? Relative humidity is equal to absolute humidity divided by absolute humidity of saturated vapor into 100. Correct? Right. Now, will this be helpful for us? A closed container of volume 500 centimeter cube. Volume is given. Okay, volume is given. Why is this value given? Then we can find the gram. Okay, people. Sorry. Okay, sorry. Now relative humidity. Relative humidity is 30. Wait. Sorry. We'll start this way. First of all, I will apply the equation, absolute humidity equation, that is mass of water vapor, okay, over volume. So relative humidity is given as 30 gram per decimeter cube. That is equal to mass of water vapor and volume. Now 500 centimeter cube means how much? 0.5 decimeter cube. So the mass of water vapor inside that will be 15 grams. Already we have mass of water vapor 15 grams, and now they are adding 2.5 grams of water vapor. When 2.5 grams of water vapor added, what happens? Mass becomes 17.5 grams. Correct? 17.5 grams. M becomes equal to 17.5 grams. Now I'm going to write an equation, see if you can understand. Now, relative humidity we know that is equal to absolute humidity divided by, right, okay. Wait, we'll find the new absolute humidity, then we'll finish now. New absolute humidity. That is, no need. Sorry, okay. No need, right? We'll use this. And relative humidity is equal to absolute humidity over absolute humidity of saturated vapor into 100. Initially, the relative humidity was 30, I believe, 30, and the absolute humidity was 30 gram per decimeter cube. And absolute humidity of saturated vapor we don't know. We'll just take it that way into 100. First equation. And in the second scenario, new scenario, RH, the new relative humidity we don't know, and the absolute humidity now is 17.5 grams, careful, 17.5 grams. I need to divide it by the volume in decimeter cube, 0.5 decimeter cube into 100 over absolute humidity of saturated vapor. Because absolute humidity of saturated vapor will not change, it will depend only on temperature. So let's divide the second one by first one. Then what will I be getting on the left hand side? I will be getting RH over 30. And on the right hand side, AH saturated will get cancelled out. 100 and 100 will get cancelled out. This is 35, isn't it? 35. So I'm getting 35 over 30. 35 over 30. Yeah. 35 over 30. So RH is equal to 35. I'm getting 35. Anyone else who got 35? 35. Yes. Only two. Right. Once again, sorry. Who got 35? Can I see? Simran and Amna Sudin. Right, good. Is this how you did? Must have done something similar to this. So this is how you have to handle it, people. I have not drawn a diagram with the systems, but I hope you can understand what's going on. I have used up the initial values to find the initial mass of water vapor, and then I have, once you add when you add 2.5 grams of water vapor, the new mass of water vapor, and then I have applied RH equation for old and new situations. Then I'm getting this. Right, so the answer for this one is fifth one. 31. Question number 31. What is it? Consider the following statements made about the forces marked on the diagram. Okay, R1, R2, mg. Mg is the force acting on the flow by the object. Completely wrong. Completely wrong, na? Why? Because mg, we'll write it here. Mg is the force given by Earth. Force given by Earth to the object. Wait. So that is the explanation for statement A. It is wrong. If statement A is wrong, this is wrong answer. This is wrong. Right. Next one. The reaction of action Mg is R1. That is also wrong. That is also wrong. Because B part, R1 and R2 are the action reaction pair. Na? Are the action reaction pair. Why is that? Because if you check the description, you will understand it. R1 means force given by table to box, and the reaction should be the other way around. R2 should be force given by box to table, but mg is not that. And the other thing, R1 and R2 should be acting on two different objects as well. So B is also wrong. Then fourth is wrong. It's either second, if not fifth. R1 is equal to R2 and R2 is equal to mg, and R2 and R1 are action reaction respectively. That's correct. This is correct. So the correct answer for this question has to be second. I mean, C is correct. You know why? C is correct because we're talking about statement C. R1 is equal to mg, people. What's the reason? That is because of equilibrium, due to equilibrium. The object is at equilibrium. According to Newton's first law, the resultant force acting on the object must be 0. The object is at rest, so the resultant force acting on the object must be 0. Mg and R1 are the forces acting on the object. And R1 is equal to R2. Why is that? Because they are action-reaction pair. Action-reaction pair. Okay. So that is Newton's third law. This is Newton's first law. Right. So hope you can understand this. 32. A mass of 10 kg placed on a smooth plane is attached to one end of a light string passing over a smooth pulley. A monkey of 6 kg climbs up along the other end at an acceleration of 2 ms minus 2. So the monkey already has an acceleration. It's given as 2 ms minus 2. 2 ms minus 2. So the monkey will have a force acting downwards. What is the force? Its weight, 60 Newton. And if the monkey is going up, definitely there must be a force acting on the monkey in the upward direction, T. And that same T will be acting here as well. Acceleration of mass 10 kg. Yeah, that's what I thought. So this mass is going to accelerate in this direction. I'll take it as A dash, because it is experiencing a tension towards right now, so it has to accelerate right, towards right, and monkey will be climbing up. Then first and foremost, what you need to do is you can apply the equation for the monkey. For the monkey, you apply F equals ma. So and direction is important. The monkey is climbing upwards, so let's apply the equation upwards. Upward force for the monkey is T minus weight is 60 equal m is 6 into acceleration is 2. Therefore, tension is equal to 72 Newton. Okay, 72 Newton. That is the tension acting on the monkey. And then for 10 kg box, you can apply the equation F equal ma horizontally towards right side. So there's only one force acting on it, that is 72. Mass is 10 into acceleration is a dash. So what is a dash, people? A dash is going to be equal to 7.2 ms minus 2. Is there an answer like that? Yeah, I'm getting the fourth one. Who else got the fourth one? Right, pretty straightforward. Pretty straightforward. No friction, nothing. This is how you have to do it. Right, next one. Due to supersonic jets, there are two sonic booms in front of and behind the jet. This is due to two sonic booms in front and behind the jet. They are air in front being subjected to high rarefaction and air at the back is subjected to high compression. So two sonic booms. Oh, what is that, people? High compression, high rarefaction. Right. So if you want a sonic boom, how do we compare about sonic boom with compression? Okay, we'll come back to 33 quickly. Yeah, I'll come back to 33. We'll circle back to 33. Trying to find a connection between. Okay, we'll circle back to 33. 34. A solid cylinder with uniform cross section is kept in equilibrium with its axis vertical in a container which contains two immiscible liquids having densities d1 and d2. When the liquid of density d1 is added, the height of immersed in the liquid of density d2 is not changed. When the liquid of density d2 is added, the height immersed in the liquid of d1 is reduced. Whichever liquid is added, the upthrust is not changed. I think C is definitely correct, no, people? Tell me, is that true or not? C should be definitely correct. Why is that? Because upthrust is equal to who? Mg, right? Upthrust is equal to mg. They're asking for true statements. Upthrust is equal to mg. So you, no matter how much liquid you are pouring, the what do you call that? What upthrust means? Is that? I hope they are talking about the total upthrust. This liquid will give an upthrust. This liquid will give an upthrust. So I think they are talking about the total one, right? So it's equal to mg. Mg doesn't change. Mg doesn't change. Due to mg, it will try to go down, but upthrust is acting upward, so object doesn't sink. So what? Let's see what will happen if you pour liquid of density d1. What will happen? Mm, if you pour liquid D2, then we are increasing the submerged volume, no people. When you pour liquid D1, what happens is that liquid will go down. Therefore, the submerged volume of the object in D2 will not change. D2 will not change, it will remain as it is. So the submerged volume in D1 also should not change, otherwise upthrust will be changed. Total upthrust can't change because mg is the downward force, total upthrust is the upward force. So first statement, when the liquid of density D1, which is at the bottom, is added, the height immersed in the liquid of density D2 is not changed. Yeah, I think that's correct because the upper part of the object is outside. No? So this is the volume of liquid inside D2. This is the volume of liquid inside D2. This. So that can't change the people. As long as the height of D2 doesn't change, this part cannot change. Correct? If you're going to maintain the height of D2 constant, the part I have highlighted in green color, it is going to remain constant. That means the upthrust created by this part will be constant. Therefore, the bottom part also can't change. So this green part is volume of object immersed in liquid of density D2. So if D1 is poured, this submerged volume doesn't change. Since total upthrust is equal to weight, since total upthrust is equal to weight, since total upthrust is equal to weight, submerged volume in D1 should also not change. Submerged volume in D1 should also not change. Okay, right, because if you pour D1, D2 will continuously keep floating. So this volume, submerged volume, is not going to change. But in B, it doesn't happen that way. B, it's going to be slightly different. What's going to happen in B? Let me show you. In B, people, this is what's going to happen now. Let's draw the diagrams again, small diagrams. When you pour D2, what will happen? The object will be like this. Okay. When you pour D2, you are increasing the height of D2 because it will be floating on D1, no people. It will be floating on. So initially D1 is like this. This is D1. This is D1. Oh no, D2. Sorry, D2. This is D1, and D2 is less denser than D1, obviously. And if you add more D2, what's going to happen? The height of D2 is going to increase. Then the object will float more. Why is that? Listen now. When you increase the height of D2, people, okay, upthrust due to D2 is going to increase. When you increase the height of D2, when you pour D2, it will float. It will just settle here. So when you increase the height of D2, upthrust created by D2 will increase. But the total upthrust can't change. No? The total upthrust can't change. So if upthrust created due to D2 is going to increase, upthrust created due to liquid D1 should decrease. So this will happen. When the liquid of density D2 is added, the height immersed in the liquid of density D1 is reduced. Yes, that's true. So the explanation is this, people. When more D2 is poured, height of D2 will increase. So upthrust created by D2 will increase. But who is constant? But who is constant? But total upthrust is constant. Total upthrust is constant. So upthrust created by who should reduce? D1 should reduce. So submerged volume in D1 should reduce. Submerged volume in D1 should reduce. I think all three statements are okay, we were correct. All three statements are correct. So you have to read the question carefully. Who is poured? The one which is floating or the one which is underneath? And I'm getting a fourth one as the answer. What are your answers? What are the answers you guys got? If you have any doubts, you can ask me. It's somewhat of a complicated question. Yeah, if you need any clarifications to be made, you can discuss. Maybe now imagine you pour more D1. What will happen? When you pour D1, that will go down, and this D2, height of D2 will not change. So this D2 will go up. With that, the object will also go up, but the amount of objects sunk inside D1 will not change. But if you pour D2, you are increasing the height of D2. Therefore, the upthrust created by D2 alone will increase, but the total upthrust can't change because total upthrust is equal to mg. Therefore, upthrust created by D1 should reduce. If you want the upthrust created by D1 to reduce, the volume of object submerged in D1 should reduce. Okay, 35. An object starting from a point A of the perimeter of a circle moves with a constant speed v, emitting a sound of frequency f naught. Right. The variation of the apparent frequency heard by an observer at point x with the distance is best represented by. With the distance. What? What do you mean by that? An object starting from point A of perimeter of a circle moves with a constant speed v, emitting a sound of frequency f naught. The variation of the apparent frequency heard by an observer at point x with the distance is best represented by. We can plot the graph with time, but what do they mean by distance, people? Confusing, huh? Distance. Distance means the distance covered by this person, this thing. I don't know. Whose distance is that? Point x, okay. So which distance are they talking about? Is it the distance covered by the object along the perimeter? In the previous question, can there be an instance where object is settled in liquid with lesser density only when we add more liquid or with higher density? No, that's not possible. I didn't get you. What is it? Sir, in the previous question, can there be an instance where object is settled in liquid with lesser density only when we add more of liquid with higher density? Yeah, in the sense, yes. When you add liquid of higher density, it will stay this way, but it will go up. I mean, the amount of it. Amount of the submerged volume in the liquid with lower density will be constant. No? So this volume will also remain constant. So as you keep pouring D1, this level will go up. As that level goes up, this object will also go up. I don't know if that was your question. Now this question is, the third one is a bit, the 35th one, it has, I mean, it's a bit confusing, people, because I don't know which distance they're talking about. Now the person is at x, no? Where? The person is at x. The person is at x. So his distance is not changing. So shall we take it as the distance traveled by this object along the perimeter? It is similar to time. Time and distance are proportional because the speed is constant. No? So I will take it that way, distance. So now this one will come here. Now here, when the object comes here, now here the distance is 0. And what's the distance here? Here, when the object comes here, the distance is 2 pi r by 4, correct? And when the object comes here, the distance traveled by the object is 2 pi r by 2, right? And when the object comes here with the same speed v, then the object will go up here, and then object will come here. So here x is equal to 2 pi r by 3, and finally when the object comes back here, x is equal to 2 pi r, because the observer is not moving anywhere, only the object is rotating. People, at this point, what is the frequency heard by the observer? Sorry, what is it? There's no Doppler's effect here because it's the direction like this. So there's no Doppler's effect here. Therefore, at this point and this point, the observer will be hearing the same frequency of the source. And where will it be maximum? It will be maximum somewhere here. It will be maximum, sorry, it will be maximum somewhere here. Somewhere here, it will be maximum. Not at A, it's not at A, should not be at A. At A, it's not going to be maximum. No? It's not going to be maximum at A, it's slightly, when it's slightly down, when it is directly towards X, it will be maximum. And here it will be minimum. Here, you draw a line from this point, a tangent here. So when your what is it? Object. The object is moving this way, maximum apparent frequency, and at this point you will get the minimum apparent frequency. So maximum 0 and then minimum and again 0. At point at the beginning it will be higher than if not. What is the answer? At A it's going this way, so maximum will be reached. Then 0 in the sense f naught will be heard at this point. F naught will be heard at this point also. F naught will be heard. 0 in the sense there is no Doppler's effect. What is the answer? Yeah, looks like the fourth one is the best choice out of these, no? Fourth one is the best choice because maximum, then F naught, minimum, then F naught again, and maximum. Maximum. But at A, how can it be maximum? That's the problem. Right. So looks like fourth is the best choice, people. Fourth is the best choice. Because when your object comes here, it will hear F naught. Wait, I will put that in steps and finish this off. Wait a minute, sorry. Let's draw it in steps and explain it to you. This one, and then another one here. So who is the observer now? Observer is at X, right? Okay, fine, sorry. Observer is at X. So people, listen to me carefully. The observer is at X. First of all, when the object is moving like this, when it appears to move directly towards the observer, like this is our source with F naught frequency. The observer here will hear the maximum apparent frequency. Okay, and when the source comes to this point, and our source is like this, okay, moving with F naught, And at that point, what will be the frequency heard by the observer? Frequency heard by the observer will be what? F naught, the same frequency of the source, because there's no Doppler's effect here. And then after a while, when the object goes here, away from the observer, this is the source, and the observer will hearing minimum frequency. The source, he will be hearing what? He will be hearing same this. So see, f max, f naught, f minimum, f naught, max, f naught, minimum, f naught. Understood? So I think question number 40. Right. So what is question number 40? The diagram shows the two wheels rotated about a fixed horizontal axis by means of a belt. Whenever you have a belt like this or a chain like this, you should know the tangential speeds will be equal. The tangential speed is equal because the belt at whatever the speed comes from here, it will reach this point. No? So the tangential speeds, not angular velocity, tangential speed. This is v1, and here it comes here, it will be v2 v1 and v2 are equal. That's what I'm saying. But omega will be different, because in one minute, if this makes 30 rotations, this doesn't have to make 30 rotations. Okay, right. And they have given the moments of inertia as well. I1, I2, and kinetic energy of two wheels are equal. This is a very important point. Kinetic energy of two wheels are equal. So to start with, when wheels are connected by a belt, when wheels are connected by a belt, V1 it's equal to V2. So R1 omega 1 is equal to R2 omega 2. So what is R1? Right, R1 over R2 we have to find out. So R1 over R2 people, huh? R1 over R2, that is equal to omega 2 over omega 1. Okay, well, omega 2 over omega 1. And they have told that the kinetic energies are, rotational kinetic energies are equal. So I can say rotational kinetic energy of wheel 1 is equal to rotational kinetic energy of wheel 2. What is rotational kinetic energy of V1? That is half I1 omega 1 squared, half I2 omega 2 and half they are going to get cancelled out. I1 over I2 it's given to us. No, we go here. I1 over I2 they have given us. So let's make that the subject on one side. We have I1, I'm sorry, I1 over I2, and on the right side we have omega 2 squared over omega 1 squared. So we are almost there. I1 over I2 is 1 over 9. It's given in the question. Huh? And this is going to be omega 2 squared over omega 1 squared. Therefore, omega 2 over omega 1 is equal to 1 over 3. So R1 over R2 is also equal to 1 over 3. And third is the answer. How many of you got third? Yeah. Anyone got third? Remember, whenever they question, it might be a belt, it might be a chain, take the tangential speeds to be equal, then continue. Okay. Right. A circular rough disc rotates about a fixed vertical axis at a rate of n revolutions per second. Okay, n revolutions per second. N revolutions omega is given by n revolutions per second. RPS. So omega is equal to n revolutions in 1 second. So how do you convert revolutions to radians, people? N into 2 pi. You multiply that by 2 pi. No? Each revolution is multiplied by 2 pi. So radians. 1 second. Therefore, omega is in fact equal to 2 pi n radians per second in SI unit. 2 pi n radians per second. That is the what do you call that, angular velocity. It's per second, not per minute. Careful. The maximum distance from the center of the disk, a small mass can be kept so it can rotate with disk is x. So they are talking about maximum distance. So when they say maximum distance, they are talking about a limiting condition, aren't they? Maximum distance. So they are talking about limiting condition, and we don't want that to slip. We don't, with respect to the disk, we don't want it to slip. So when the disk rotates, it will stay still on the disk. On the disk, it will not slip. So it will rotate with the along with the disk. That means uh, the centripetal force acting on the object is the limiting frictional force. Okay, the centripetal force acting on the object is limiting frictional force. Mg will be acting downwards, and there will be an R upwards. All right, fine. So what is the question here now? What's the question? The coefficient of static friction. Okay, we have to find the coefficient of static friction. Right. So guys, let's finish this off. Should not be a problem. Centripetal force, it's equal to, what is the equation we are going to use? mr omega square. And what the centripetal force acting on the object this time, it is the limiting frictional force. Centripetal force acting on the object is limiting frictional force, and the limiting frictional force is equal to mu r. But we know r is equal to mg, so fcp it's equal to mu mg. Okay, mu mg. Therefore, if I substitute that on the left side, mu mg is equal to mr omega square. Right, then we'll cancel out m and m, and that will give me omega, right? What am I supposed to find out? Mu. Okay, we have to find mu, right? We have to find mu, so we'll make mu the subject. Mu is equal to r omega squared over g. So mu is equal to r over g into omega squared is this value, right? 2 pi n whole thing squared. So mu will be equal to what is going on? Did I make a mistake somewhere? People? Did I make a mistake? People? No, right? R is missing on top here. Oh, x. There's no r. R should be x, na people? Yeah, R should be x. Oh, wait. It should be x. X, not R. X. 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 Okay, well, is there an answer? Are we getting no, right? We are getting this but upside down. What chance you people got for me? I hope I'm not making a mistake. The coefficient of static friction between the mass and the disk is given by are you getting this answer I'm getting, Shimra? You guys tell me if you got this answer. 4 pi squared n squared x over g. Right, okay, then we'll settle with this now. The reciprocal of that is given in the third answer. Reciprocal of that is given as the third answer, na? Yeah, I don't think there's a mistake here. Yep, I can't think of any mistakes because we have done it perfectly. Omega squared 2 pi. Don't know whether they made some mistake somewhere. I don't know. Right? Okay. It's yeah. If you have got this answer, you can give it for correct. Huh? Question number 42. Let's see what this is about. The figure shows a swing in an amusement park. The seat of which people sit is hung with a light metal rod of length L. Light metal rod of length L. Okay. Each of these rods are hinged smoothly to ends several other rods which are connected to the main rotating rod. The angle which each light rod of length L makes with the vertical when the main rotating rod rotates with a uniform angular velocity omega. What is that? Interesting, very interesting. Read it again. The figure shows a swing in an amusement park. A swing, right? The seat of on which people sit is hung with a light metal rod of length L. Where is that? Each of these rods are hinged smoothly to ends several to ends to ends several other rods which are connected to the main rotating rod. Okay, this is a rotating rod, and the angle which each light rod of length L makes with vertical when the main rotating rod rotates with a uniform angular velocity omega. Do you get the picture here, people? Angle which each light rod makes with the vertical. Should we consider it like a, you know, what do you call that? A conical pendulum, maybe. You take it as a conical pendulum like this. If you take it as a conical pendulum, is this what they're talking about? I mean, they're talking about the angle with the vertical. That part I got it. But, something like this. Then there's the object, and this is creating an angle with vertical theta, and it is rotating omega. So I try this way. Got to figure out a equation for theta. So let's try to analyze it this way and see if we are coming up with an answer. This is mg, right? If there's an mg like this, there should be a tension created here. And what is this? Wait, sorry. What is this, people? The vertical component is going to be t cos theta. Why is that? Because if this angle is theta, this is going to be theta as well. What do you call that? What do you call that, people? What do you call that? Alternate angle. And here we have the other component, that is t sine theta, but without t. Okay, right, thank you. Then moving on, this is mass m kilogram, right? Fine. Then we have to use centripetal force equal to mr omega squared. Can someone tell me what is centripetal force acting on the rod? Centripetal force of the on the object, it is going to be t sine theta, right? T sine theta. It's going to be t sine theta, and this length, mind you, this length is the radius of the circular path it's going to take, and this length is going to be this length is L. This is going to be L, the total length of the rod. They have given it as L. This is L. What is this length? This length, this is our R, and that is going to be equal to L cos theta, L sin theta, right, people? L sin theta, L sin theta. So T sin theta is the centripetal force, equals to M, instead of R we can put L sin theta into omega square. Moreover, we know upward force should be equal to downward force because the object is performing a horizontal circular motion. So upward force is T cos theta, downward force is mg. So we can say T is equal to mg over cos theta. If I substitute here, mg over cos theta equals, into sin theta equal to m into L into sin theta into omega square. I think this is the one, people. So m will get cancelled out. No? M will get cancelled out. One sin theta is going to get cancelled out. So let's make cos theta the subject. If I make cos theta the subject, what will I get? Cos theta on the right side. On the left side, who will be there? G is there. L goes down. Omega squared comes down. So G over L omega squared. So finally, theta is equal to cos inverse G over L omega squared. Can I know anyone else who got this answer? I think this answer is there. Yeah, the third one, right? Okay, Shimra has got it. Good. Anyone else? This is about a conical pendulum. You have to think of it as a conical pendulum and do it. Okay, because when it rotates like this, the rod will, when they say rod is making an angle with the vertical, this is the diagram you should have come up with. So the answer is third. The rotating blade of a helicopter of mass 1750 kg is 5 meter long. When the blade rotates one complete round, the effective area of air swept by the blade is 40 meters squared. Density of air is 1.2 kilogram per meter cube. For the helicopter to travel upward with an acceleration of 2 ms minus 2, the velocity of air should be pushed down approximately given by. Awesome question, right? Nice. So you all might remember how a helicopter works. We have the body of the helicopter, goes down like this, and then it has this, wheel on top, the blade on top, right? So when it rotates, it pushes air downwards. It pushes air downwards. So it will push air downwards like this, and it pushes air downwards at a speed of what? That must have been given somewhere. Haven't they given? That's what we have to find out. We need to find that out. So when it pushes air downwards, what will air do? Air will push it vertically upwards. Air will push it vertically upwards like this. Lift force given by air. Lift force given by air, and also there will be the weight of the helicopter, mg, but we want the helicopter to go up with an acceleration of 2 ms minus 2. 2 ms minus 2. Okay, right. So we know blade of helicopter pushes air downwards. So air gives an equal and opposite force upwards. Newton's third law, and second law will also be involved here. Equal and opposite force upwards. Right. What is the equation for the lift force, people? If you go to Newton's second law, we know F equals mv minus mu over t. If you take m this, if you take m out, m over t into v minus u, right? But we know m over t. But m over t, that can be written equal to volume into. No, I'm not going to waste my time. What is the equation for m over t? Mass flow rate. It is AV rho, isn't it, people? AV rho. Volume flow rate multiplied by density, mass flow rate. So finally you will be getting what? AV squared rho, AV rho into V, and finally it will be so the lift force, actually the lift force is given by AV squared rho. Some of you might be already remembering this. If you can't remember, this is how you have to derive it quickly. Let's say you have forgotten it. AV squared rho, that is a lift force. So for helicopter, now let's apply the equation upwards. Helicopter, we are going to apply the equation upwards, F equal ma, and if I substitute the values, the lift force minus mg equals ma. What is the lift force, people? AV squared rho minus mg. What is mg? 17,500 equal to 1,750 into 2. If I continue it here, effective area is given, no? Here, when the blade rotates one complete round, the effective area of air swept by the blade is 40 meters squared. So 40 into v squared, we have to find out. Density, it's 1.2 equal to, this goes to the other side, and that is this is 1,700, that is 3,500, 21,000. So people, I'm getting v square equal to 21,000 divided by 40 into 1.2. Anyone simplify this? I don't like this answer. Something is missing. 3,500. Okay, 21,000. 21 is there, no, people? Approximately 21. What do you mean by that? Approximate, the final answer. Okay, right. Then how do we do it? Okay, then you are saying, but I want to simplify it and get it. Wait. 48 at the bottom. Yeah. Could have done that, no? Without wasting time. Yes. This one you can write this way. 40. Azan people, so I'm not going to talk. I'll just write the important parts. You can rewrite the equation this way. A is 40 into V squared to 1.2 minus 1750 into 10 kilograms equal to 1750 into 2. So this 40 into 1.2 or 48 V squared. Twelve into 1750. So V square is in fact V square. Come on. Root of 70. Roughly 21, no people? Roughly 21, yes. Well, we're done with 43, and this is how we do it. Whether we like it or not, this is how we will have to get the answer, right? Let's continue from there onwards. The next question is from, so the 44th one. A car which starts from rest travels with a constant acceleration. If the final velocity is v after a total of n seconds, the distance traveled during the last m seconds is given by what? A car which starts from rest travels with a constant acceleration. If the final velocity is v after a total of n seconds, the distance traveled during the last m seconds is given by last m seconds. Last m seconds means, should it be after last m seconds? Interesting. Last m seconds. Last m seconds. Okay, let me put a diagram like this. Shall we try to do it with VT graph? Try to do it with VT graph. The graph has to be like this, no? Starting from rest, it should increase like this. No, velocity with time. And after n seconds, velocity is v. The question is, what is the distance traveled during the last m seconds? They're asking for this distance. Do you agree with me? During the last m seconds, we need to find this distance. Okay, this one. Oh, okay. So m is okay. M is there, and I need these two values. I don't know where m starts, right? So one thing we can say is this. One thing for sure, that is the acceleration can be directly found. How? Now when you apply v equal uat, final velocity v, initial velocity is 0, acceleration a into time n. So acceleration is equal to v over n. That okay. Acceleration is equal to v over n. Distance traveled during the last m seconds, I need these two values. Good. How do we find this value? During last m seconds. Final velocity is v after a total of n seconds, the distance traveled during last m seconds. So I can take this velocity as an unknown. May velocity find that unknown people. Or should we say after n seconds, the next m seconds? Should we take it that way? Did you take it that way? We'll take it that way, no? Equations, Shimrana, we don't know where the last m seconds starts. Last m second means, no, you can do it with equations, but last m second means where are we going to start now? Let's say that it traveled in last 2 seconds. Total time t t. Then total time we don't know. The final velocity is v after a total of n seconds. Oh, okay. I think I'm making a mistake here. Sorry. We'll take it this way. Yeah, sorry, wait. I think my diagram has a small error there. It should be this way. Final velocity is v, isn't it? Final velocity is v. Final velocity. So I should mark v here. This is v. And the total time is n. Okay. Total time is n. That's what they have told in the question. So, okay then. That's okay. And can someone tell me what this velocity? We don't know. I'll take this velocity as v1. So if this area, people, okay, this area will give us the distance traveled during the last m seconds. Distance traveled during last m seconds. Last m seconds. So what is the time taken up to this point? What is this time? This is going to be n minus m seconds, correct? N minus m seconds. So to find v1, we can put to find v1. Okay, to find v1, I'm going to use v equal u plus at. Final velocity is v1, initial velocity is 0, okay, plus acceleration for the time being, let's put it as a, into time n minus m, correct, n minus m. So v1 is equal to a times n minus m. Substitute for a later. Okay, right. So distance traveled during last m seconds, I'll take it as d or some value. Okay, so d is equal to area of trapezium. Area of trapezium. What is area of trapezium? Half into addition of the parallel sides v1 plus v2 sorry, v1 plus v into the height m. Okay, so half into what is v1, this a into n minus m plus v into m. Then half into, for a, let's substitute for a, let's put that value, that is v over n, v over n into n minus m plus v into m. Is there an answer? I think we can take this v out, which is common. So I'll continue it here. The d value, that is equal to half, yeah, half will be there. Half is there, then v comes out. I'm getting mv by 2. Why is that? mv by 2, and inside the bracket we have, 1 over n minus m plus 1. Okay, what do you think they have done after that? Okay, let's continue. mv over 2, inside they, I think they are taking n as the LCM. So when you take n as the LCM, you will be getting n minus m plus n. So there is a 2n inside. So d equals mv by 2n minus m over n. And I think they have multiplied this 2 in the 2 mv inside the bracket. I have a 2n minus m over 2n. Okay, then you divide everything by 2n separately. So d is equal to mv inside the bracket 1, 2n over 2n is 1 minus m over 2n. Is there an answer like that? I think there's an answer like this. Third one is the answer. Anyone who got this answer? Maybe you might have used an equation. I don't know. Got it? Is there a lag in my screen? Others? Says there's a lag in my screen. For the others? Using mobile data, I don't know whether the connection is strong. Hello? Okay. Interesting. Oh. Am I audible, people? Rough shape of the graph which shows the variation of kinetic energy of an object with its linear momentum, right? Kinetic energy versus linear momentum. So we have to find the relationship between kinetic energy and linear momentum quickly. Let's get started. What is the right? Kinetic energy is E, linear momentum is P. So we know E, oh wait, we start with P. P is equal to mv, right? Mv, and E is equal to half mv squared. Well, multiplying either side by m, multiplying by m. On the left side I'm getting me, on the right side I'll be getting half m squared v squared. The reason for doing that is I'm getting momentum on the right side, see, p squared. So me equals half into p squared. So if I make E the subject, I'm getting 1 over 2m into p squared. So mass of the object is a constant. It is for an object. Mass of the object is constant, so gradient is constant. Therefore, E is proportional to p squared. E is proportional to p squared. When E is proportional to p squared, if you draw the graph for E and p squared, you will be getting a straight line like this. But the graph is not for E and p squared, mind you. You'll be getting a straight line like this. But the graph is for E and P. For this relationship for E and P, if you draw the graph, it will be curved like this. So the answer is fourth one. Because when you increase P by 1, 2, when you say it's 1, 2, 3, 4, what will happen to E? E will be 1, 4, 9, 16, 25. So when you increase P 1, 2, 3, 4, 5, E will increase 1, 4, 9, 16, 25. So E will increase fast like this. The answer is what? Fourth one. In case they had given E versus P squared, second is correct. Right. Next question. The time taken by a ball which is thrown at 60 degrees with the horizontal to move at an angle of 30 degrees with the horizontal. So this is a projectile motion question, a very interesting one. This is what happens. You're throwing it at 60 at the beginning. Then what will happen? The object will do this, and at one point it'll become flatter. So now the object will be here moving like this with an angle of 30. Okay, so it will have an initial velocity of u and initial angle is 60, right? 60 u, and this is 60. So there will be a horizontal component here. What is this horizontal component? U cos 60. U cos 60, and here we will have if I take this velocity as v, this will be v cos 30, and we know v cos 30 should be equal to u cos 60, right? And here we will have a vertical component. Vertical component is u sine 60, and here vertical component is v sine 30. So the timing they are asking for the time. So here time is equal to 0, and here time is equal to t. So this is very important. I mean, I will leave it like that, and then we'll analyze. I have taken the velocity at this point as v. I have taken the velocity at the initial point is u. So the components are taken this way. They're asking for the time. Horizontal velocity component remains constant. No? Horizontal velocity component remains constant. Velocity component remains constant. So you can say therefore u cos 60 should be equal to v sine 30, right? V sine 30. This angle is 30, that's important. So u cos 30 u into half, that is equal to v sine 30. Yeah? V cos 60 cos 30 sorry, not sine 30, cos 30, apologies, that's what I was wondering, right? Cos 30, so it's in root 3 over 2, therefore this half and half will get cancelled out, so I'm going to get v is equal to root 3, u is equal to root 3 v, u is equal to root 3 v. So I'll take these 2 points as a and b, a b. Now from a to b, I think we can apply upwards v equal u plus at, right? V equal u plus at. So the upward velocity is v sine 30 equal to upwards initial velocity is u sine 60 plus acceleration is going to be minus 10 because gravity will act downwards. I'm applying equation upwards into t. So I'm getting 10t, that is equal to what? 10t is equal to u sine 60 minus v sine 30. Okay. Fine. Yeah. Then we will 10t, it's equal to u sine 60 means u into root 3 over 2 minus, for v we can substitute this value, no? For v we can, no, wait. So from this we can say v is equal to u by root 3, no? U by root 3. So u by root 3 into sine 30, that is half. Any progress? There is a u, we need to get rid of this u. We can find that u, it's not that complete time, 30. Vertical velocity, we can find it. Horizontal velocity also we can find it. So you can find v. Wait. I think if you approach this way, u will be an unknown. There is a small problem there, people. If they had given time and if they ask you to find u, you can do it this way. Right, I'll try to change the approach a little bit because now I'm getting stuck here, unfortunately. Yep, I'm getting stuck here. I'm gonna 10t. Okay, 10t is equal to, if I take 2 root 3 as the LCM, it will be 3u minus u, that is 2u over 2 root 3. So that is u over root 3. Means time is equal to u divided by 10 root 3. But I don't have u. I need to find out u. So I'm stuck there. I think we found, that's time, we don't know the time. U. So if I can find a way to find out, if I have a way to find this u, then I have my answer. Anyone who tried this got the answers? Okay. By root 3. We didn't use this 30. Yeah, use this 30 effectively. That's what I'm thinking. So this force, this one and this one. That's what I've tried here, but it didn't work out.